let's graph this rational equation, this rational function. First step to do when you're graphing rational functions is to factor the top and the bottom. That's going to help you with a lot of the stuff that you need to know. So that's how they factor. Notice there's no factors in common, so I don't have any removable discontinuity or holes. I don't have any of those because none of the factors cancel out. My vertical asymptotes have to do with the denominator. Remember, the denominator can't be 0. So the vertical asymptotes are, I'm going to set each one of these factors equal to 0. X equals 4 and x equals -1. So let's start graphing this over here. X equals 4, that's a vertical asymptote, and x equals -1, that's a vertical asymptote. The horizontal asymptotes we find by looking at the degrees of the numerator and denominator. Since the degrees are the same, the horizontal asymptote is equal to y equals the ratio of leading coefficients, which is just 1 over 1, which equals 1. So there's our horizontal asymptote. We also might want to find the the x-intercepts. The x-intercepts are found by setting the numerator equal to 0. So that's just x equals 1. And notice how it's right here. So there's our x-intercept right there. Now, here's the tricky part. Technically, you can cross a horizontal asymptote. You just can't cross it at infinity. So we still need to determine if this graph goes down like this or if it goes up like this. We still have to determine that. We don't know that yet. So let's figure that out. How do we figure that out? We do a little sign analysis. Let's plug in a number. Let's plug in 3 right here to this equation, to the original equation, and let's see what the sign is, if it's positive or negative, or really what the value is, if it's a positive number or a negative number. So 3 squared, let's do this in our head, 9 minus 6 plus 1, that's a positive number. 9 plus 9 minus 4 is also a positive number. So that is actually a positive value. So it does in fact go up. Don't be confused. It doesn't matter that it crossed the horizontal asymptote because it's doing that in this finite space right here. It's not crossing it toward infinity. It's crossing it and then never crossing it again. So now let's determine what the graph's going to do over here. Well, we kind of know what the graph's going to do because the only x-intercept that we had was positive 1. Since that was the only x-intercept, we know that this graph has to be above this line. It can't be below it, approaching infinity, because then it would have to cross over the x-axis, but we know it's not going to do that. And same with up here. It's not going to cross the x-axis anywhere, so we know that the graph's going to do something like that.
Okay, yeah.
And so that's how we graph that, and you can check it by plugging in a number, let's say -4, and making sure when you plug it in that it works, that it's a positive number just above 1, something above 1. So let's do that. -4 squared is 16 plus 8 plus 1. -4 squared is 16 plus 12 minus 4. Those are both going to be positive numbers. And so that does in fact check out, and the other one would check out as well.